All right, let's get right into it. We are swimming in a sea of text data. Tweets, reviews, you name it. And machines, they're amazing at collecting all of it. But actually understanding what it all means, well, that's a whole other ballgame. Today we're going to talk about this incredible team-up between human brains and machine power, and how they work together to crack the code of human language.
Just think about a word like smoking. Seems simple, right? Well, if you're doing a health study, you're obviously thinking about cigarettes. But on social media, that same word could be about a delicious barbecue, or someone who looks great, or even a really fast car. For a machine, that's a total nightmare.
And that's really the heart of the problem. Machines are unbelievable when it comes to scale. They can sift through 1,000,000 data points before we've even finished our coffee. But what they almost always miss is that one thing that matters most: context. They just don't get the inside jokes, the sarcasm, the stuff that we humans get instantly.
And you see this problem everywhere. You look up United. Are you talking about Manchester United or United Airlines? You search for Christie. Is that the politician or the author Agatha Christie? And don't even get me started on Patriots. Is that the football team or a political group? See, without a human to provide that context, the data is basically useless.
So if machines are lost without context, what's the fix? Well, this is where we get to the first part of the answer, and it's all about playing to our strengths as people.
The solution, believe it or not, is us. It's people. We're basically walking, talking context machines. Nuance is our native language. We can spot the difference between a tweet about smoking ribs and a tweet about quitting smoking in like half a second.
And look, this isn't just some feel-good idea. It's the core principle of a system like DiscoverText. This quote really says it all. Human coding isn't just some add-on. It's the absolute heartbeat of the whole operation. It's what makes the machine smart in the first place.
And don't for a second think this is slow work. When you give a human coder the right tools, we're talking simple things like keyboard shortcuts, they become incredibly fast and accurate. A single person can correctly categorize 150 to 200 items an hour. That is human-level understanding, moving at almost machine-level speed. Okay, but here's the twist. Just when we think we've solved the machine's problem by bringing in people, we run into a whole new problem. The problem with people.
You bring in a team of smart humans to provide that clear, consistent context. But what happens when two of your experts look at the exact same piece of text and totally disagree on what it means? Now who do you believe?
And you know what? This is going to happen. It's unavoidable. We're all shaped by our own experiences, we're subjective, we get tired, we make mistakes. It's not a flaw in the plan, it's just part of being human.
Now here's a really important point. The software itself can't fix this. It can't listen to the two arguments and decide who's right. But what it can do is act like a referee. It can throw a flag on the play and say, hey, we've got a disagreement over here. The tech can't solve the issue, but it makes the issue impossible to ignore.
So this is where things get really, really clever. How do you take all that human subjectivity, all that messiness, and actually turn it into a major strength?
First up, you use a tool called inter-rater reliability. You can just think of it as a teamwork score. It's a number that tells you how consistently your coders are all following the same rulebook. If that score's high, you're golden. If it's low, you know you've got a problem to sort out.
So when the system does flag a disagreement, what happens next? It's a process called adjudication. It's pretty straightforward. Multiple people code an item. If they disagree, it gets flagged. Then, a senior coder, or a rule you've already set up, makes the final call. And that decision, that becomes the gold standard. It's the official, correct answer. And once you start doing this, you discover a pretty provocative but powerful truth, one that this quote sums up perfectly. When it comes to a specific task like this, some people are just flat out more accurate and consistent than others.
Which brings us to this brilliant idea called CoderRank. Seriously, think of it just like Google's PageRank. Google doesn't treat all websites equally, right? It ranks them. CoderRank does the same thing, but for your human coders. It scores them based on how often their answers match that gold standard over time.
So after a while, you get a clear picture. You can see that Coder A is hitting it out of the park with 98% accuracy. Coder B is doing great at 91%, and Coder C is at 84%. They might all be good, but now you know, with data, who your absolute rock stars are. And that is a game changer.
And this is the moment it all clicks into place. Because once you can reliably rank your humans, you can use that knowledge to make your machine exponentially smarter. You create this amazing self-improving loop.
Think about it. Instead of teaching your AI model with data from everyone, including the occasional mistakes, you train it using only the data that has been validated by your top-ranked, most reliable humans. You've heard the phrase garbage in, garbage out, right? Well, this is the complete opposite. This is gold in, gold out.
The whole system is called an active learning loop. It works like this. Humans code. CoderRank figures out what the best, most reliable coding is. The machine learns only from that gold standard data. Then the machine goes and applies that learning to the whole massive data set. And anytime it gets confused, it sends the tough cases back to the humans. Every single time you go through this cycle, the whole system gets smarter.
And this isn't something you just do once. It's a constant process of refinement. Round and round the loop goes, and with each pass, the data gets clearer, the model gets sharper, and your understanding of the topic becomes incredibly solid. So if you're going to remember one thing from all of this, let it be this mantra right here. You have to validate everything. Yes, validate your AI models, but just as important, you have to validate the judgments of the very people who are teaching those models. It's all about building a chain of trust from start to finish.
So let's wrap this up. What are the big takeaways? 1. The absolute best text analysis happens when you team up machine scale with human nuance. They need each other. 2. Just hiring humans isn't enough. You have to actively manage and measure their work to get data you can actually trust. And 3, this whole approach puts you in the driver's seat. It lets you crack open that black box of AI and build a system based on metrics you actually understand and control.
So I'll leave you with a final question to chew on. We're always hearing about how smart AI is getting and how it's going to replace people. But maybe we're looking at it backwards. What if, as machines get even more powerful, our ability to guide, measure, and validate the human wisdom that teaches them doesn't become less important, but actually becomes the most valuable skill of all?